prime number is any number that is divisible by 1 in itself. So 7 has 1 in itself. An example of a number that's not prime would be 6. 6 has 1, 2, 3, and 6. When Euclid made his Euclid Elements, they did not have algebra back then, so he defined prime numbers with lines and circles. His definition of a prime was, a prime number is that which is measured by a unit alone.
So we have a line of length 7, we'll say. Euclid's definition meant that this line can only be divided into units, as shown here. So this means that if you try to make this line out of 2 unit pieces, it will not fit. That's the basis for his explanation as to what a prime number was.
Using Euclid's example, we will use a line with the measure 4 and show that it can be separated into units of more than just 1.
Primes become really useful in mathematics when it comes to something called prime factorization, which is when you break a number down into its unique prime products, such as, say, 12. You're going to have it broken down into 2, and then 2 and 3. This is called prime factorization, and there's a very important theorem about this. It's called the fundamental theorem of arithmetic, and this says that any positive integer can be expressed as a unique product of primes.
One example of how this applies to numbers would be the factorization of 30, which would be 2, 15, which also gets further factored into 3 and 5. So when we're writing this out, 30 is expressed as 2 times 3 times 5. So why isn't 1 considered a prime number?
1's not a prime number because if it were, no number would have a unique prime factorization. For example, 6 is broken down into 2 times 3, but if you included 1, it would also be 6 is equal to 2 times 3 times 1, and it'd also be equal to 2 times 3 times 1 times 1, so on and so on, all the way to infinity. So how is 1 broken down into its prime factorization?
For 1, we have to visualize it a different way. So we're going to start off with 27. 27 is the prime factorization of 3 times 3 times 3. 9 is the prime factorization of 3 times 3, and 3 is a factorization of just 3. Now, for 1, it's something called the product of no primes, which is visually like that, other named as empty products.
Our first type of special prime is a group of primes known as Mersenne primes. These are primes that are 1 less than a power of 2. This is shown by the expression 2 to the n power minus 1.
The first real Mersenne prime number would be 3, which is the product of 2 to the second minus 1.
Our next example of a Mersenne prime is 7. This is 2 to the power of 3 minus 1, which gives you 7.
If we simply increased n by 1, we would have 2 to the 4th power minus 1, which is 15. And 15 is not a prime number because its prime factorizations are 3 and 5.
The next example of a Mersenne prime is 31, which is 2 to the 5th minus 1.
Twin prime numbers are prime numbers that are 2-digit places away, like 3 and 5. The smaller of the two is called a chin prime.
Another type of special prime is known as a palindromic prime. This is much like a language palindrome, which is spelled the same forwards as it is backwards, and a palindromic prime is written the same forwards as it is backwards. Examples of these are 11, 101, 373, and 787.